Welcome, welcome, welcome. It is so good to see you on this Wednesday afternoon. And in front of you, we have the last two sections of chapter 2 to be working with. Now, we are going to be talking a little bit more about isosceles triangles. We've already done some in the past, so some of the questions for homework in 2.5 are going to be ones that you've seen in the past or some similar ones, but that's how our book works. They sometimes go forward 2 steps and take a step back. This is a section where some of the stuff we may have done is going to be part of your homework, which is great. Now, 2.5 and 2.7 happen to be some review stuff that you may already know. So I'm going to move through them a little quicker. If you find I'm going too fast, let me know. Now, isosceles triangles. We've already talked about them. But remember the vocabulary. Up here is the vertex angle. Down here are my base angles, and my base angles are equal, okay? Because my two legs are going to be equal. Now, with that said, this is the new type of question you're going to get. Now, they're going to give you a blank triangle. They have not put X, Y, and Z on this picture. The reason is they want you to understand what that line means. Okay, it says X, Y, Y, Z. Notice that the Y's repeat. That means Y is my vertex angle. That means X can be on my right and Z can be on my left. X and Z can be in opposite places, but the Y can only be in one place, the vertex. Now, knowing that, angle X is 72, which means angle Z is 72. They're asking you to find the vertex angle. That is 72 plus Y plus 72 is equal to 180. 144 plus Y is 180. Now, remember, we're talking angle Y, which means I've got a little degree symbol. And this is going to give me 36 degrees. Okay. Are there any questions with what I did? Okay. Now, this one. Okay, again, blank triangle, but they gave you a picture, but they didn't label it. Again, notice that the Y repeats, which means, again, Y is my vertex. This is X, this is Z. Now, we got to do a little algebra here. X, which is in this corner, happens to be 6x plus 4. Z happens to be in this corner. And if you remember, X equals Z. They're base angles. But this means we got to do a little work. We're going to have to find x first, which is 6x plus 4 is equal to 10, parentheses x minus 2. 6x plus 4 is equal to 10x minus 20. Now, I have 4x is equal to 24. Now, I found x, but I'm not finished yet. I want the vertex angle. That means I'm going to come back up here and put 6 in for x. Well, 6 times 6 is 36 plus 4 means that angle x is 40 degrees. But that also makes angle z 40 degrees. Angle y 180 minus 80, because 40 plus 40, okay, is 100 degrees. Now, are there any questions with this one? Okay. Yay! Now, here's where the fun comes in. Okay. Now, this one, they've given you A, B, C, but they've marked the triangles. Now, right away, notice angle C and angle A have the same markings. Now, why is that important? Because I have 3 sides in this figure. 2 of them are equal to each other. It is the CB and the AB side. The sides opposite where A and C are equal. 4x minus 1 is not going to be part of my algebra to get x. Now, are there any questions with why I'm going to take 2x plus 6 and set it equal to 3x plus 3? I'm reading the markings. If I don't read the markings, I am not going to be able to solve this equation. Huh? Any questions?
Yes. Excuse me. I'm sorry. Wait, so why, how did you know that those two are equal?
Look at the blue circles, Bridget. Do you see the markings on angle A and angle C are the same?
Yeah, no, I see that. I'm just trying to understand why it wouldn't be 3x plus 3 and 4x minus 1.
Because it's the sides opposite where those angles are equal. The opposite to C is this side, Bridget. The opposite to A is this side. So the red and the green sides, based upon markings and our knowledge of isosceles triangles, tell me that 2x plus 6 is equaling 3x plus 3. That's my algebra.
Okay, then thank you so much. I got like colored markers to try to keep up. Thank you.
No problem. And yes, Christopher, it is always the opposite angles alone mean the attached sides. Now, it's the opposite side. The C goes to the red side. Angle A goes to the green side. Those are the two sides that are equal. Does that help you? Okay. Well, now we can find x, and this is real simple. This is x is equal to 3. I got x. Okay. AB is going to be 3 times 3 plus 3, or 12. AC is going to be 4 times 3 minus 1 is 11. And BC is 2 times 3 plus 6, which is 12. And see those two numbers? They're the same.
Okay.
Any question with this? You are now experts at reading markings. Yeah, you are. Some of you are shaking your head no. The answer is yes, you are. You now need to read the markings. You need to read the symbols. Now, let's see what you can do with this one. Now, since it's a story problem, okay, I want to let you know that we have a vertex. It's not in the picture. Add it. So that means y is down here, z is here. Now, each base angle. Now, I'm going to call these base angles A. The word is means equal. Each base angle is, okay, 14 degrees larger than the vertex angle. So the vertex angle we know is x. So this base angle and this base angle are going to be 14 more than x. This is x plus 14. This is x plus 14. My vertex angle is x, which means x plus 14 plus x plus 14 is equal to 180 degrees. Now I have 3 x's plus 28 is equal to 180. Now, 3x, if I subtract 28 from both sides, I get 2. This is going to give me 152. Divide by 3. Okay, x. Now, this is where you've got to understand Mom. This set of information that was given, it doesn't tell me to write a decimal answer. This is going to be 50 and 2/3 degree. This is a mixed number.
I have a question, ma'am.
Hold on a second. Okay. Go right ahead. Question.
How would you determine that the X is on top and that the Y and Z go in that position that you put it in?
See, it says vertex X.
Oh, okay.
No, please ask me, because you are going to get homework problems in 2-5 where they're expecting you to understand what the words to the parts of an isosceles triangle are. Vertex means vertex angle. Okay. Okay, John, the answer is no. He said, could you write a decimal, or would Mom say it's incorrect? Well, I'm going to let you know that 2/3 is what we call a repeated decimal. Unfortunately, 2/3 is a 0.666666666 on forever. When it doesn't ask you for a decimal by telling you to round off, you have to give them a mixed number. They will tell you it's wrong. Now, you might get lucky, because I know that we've been trying to avoid, the fact that some students like to use a calculator, some students don't. But unfortunately, Mom has been one of these programs that if it doesn't say give a decimal, you must give a mixed number. Now, an improper fraction, someone asked me about that. Could I just leave it 152/3? Well, I'm going to let you know the answer is no. The reason is, find each angle. I know that this angle is 50 and 2/3 degree. I've got to find, and how? Well, Christopher, the answer is no. He asked me, are they all going to be nice and be 2/3? Now, not all the time. Sometimes you get 1/11, sometimes you get 3/14. It just depends on the reiteration that Mom generates when they put the numbers into your homework problem. I know you're going to be excited, Christopher. It's just the way it works. Now, Y and Z, you've got to add 14 to this. Well, remember, you're adding 14 to the whole number. This is going to be 64 and 2/3. That's going to be Z. That is going to be X. And don't forget, it's degrees. So we're working with basic math here. You should be able to take 152, and someone asked me, can I write the 2 a little better? Yeah, I think I can. I'll try. Okay, gotta close this. This is a 2. Okay. You're going to need to divide out. Now, this is supposedly basic math skills. Dividing 3 into 152 is stuff that if you got to 470, you've done basic math. You know how to get 50 and 2/3. Okay. Are there any? Oh, how would you change into a decimal? Oh, let's show you here. Okay. I'm going to use this screen, Christopher. If I got the answer 1/11th, okay, this 11 is your divisor, which means it's 11 1.00. Now, decimal's got to come up here. And this will then be a 0 and a 9. Subtract. Okay. Now, you gotta add what we call rounding zeros because everything goes in pairs. Because if I brought down this first rounding zero, I get this 0. This would give me the 9. 1/11th is the repeating decimal, 0.09 with the bar over it. Okay. Now, Christopher, you just got to get through test 1. Test 2 and the final exam, you could use a calculator. But this one, they're not letting you use a calculator. Okay. No, a lot of people have the same question. I'd rather answer it now because when you get to homework, it's kind of hard to answer questions. And you might have asked one that everybody else wanted to know. Okay. Now, okay. Let's see what you can do in the chat room with this. Okay. Now, for those of you, notice the vocabulary. Y is up here this time. Okay. X is here. Z is here. Now, I want you to figure out what are the 3 angles in this triangle. I have several people who wrote me in the private chat room, I'm lost. I can't get this. Well, okay, let's see if we can help you. We know that the base angle is X. Okay, so this is X. This has got to be X. Yay, Lupe, you got X. Okay. Now, how do we get Y? Well, notice this little word is. That means equal. The vertex angle Y, which is up here, is 10 more than 1/2 the base angle. So now we have X plus X plus 1/2 X plus 10 is equal to 180. Now, it's up to you how you want to do this. Normally, when I have a fraction anywhere, even one of them, I then get rid of my fractions by multiplying each term by 2. Now, you could subtract 10 before you do this, but it's going to come out to be the same thing. This will give me 2x plus 2x, but this 2 and this 2 are going to cancel. This will give me 5x is equal to 340, and x is going to give me 68. Yes, Alan, I'm multiplying everything by 2 to get rid of the single denominator I have in a fraction. Now, could I have kept it as a fraction? Yeah. I would have gotten, without multiplying by 2, I would have gotten 2 1/2 equals 70. Still going to get x as 68. It's up to you. Right now, your algebra is what you know how to do. Does it make a difference? No. We're still going to get x. And as you know, this angle and this angle are both 68. How do I get y? Well, 68 times 1/2 is going to give me 34 plus 10, 44 degrees. Your algebra is what you use. I like to multiply everything by 2. Even if I have one fraction, I get rid of it. Okay. Now, are there any questions? Okay. Then let's take a look at, now I'm going to skip this proof for right now. I'm going to go right to here. Okay. We've already talked about these. Equilateral, equiangular triangles. Equiangular means each angle is 60. Equilateral, all sides are the same. Okay. Now, with that said, this is what you're going to now see. Okay, Bridget, be very careful here. Okay, notice this angle, and this angle are all marked the same. Okay. Because they are all marked the same, we have an equiangular triangle. But it also means that all sides are equal. Now, this is where you got to watch. All sides are equal. But look at the fact that I have 2 letters. Okay. When I have 2 letters, I have 2 equations, which means I'm going to have to take 2 sides and set them equal to each other. But then I also have to take another side and set it equal to another side. I've got to create a system of equations. Okay, fun time. Oh, I can hear the thrill in your voice. Okay. Well, we're going to take this blue side and this blue side, and I'm going to set them equal to each other. So I have 2x plus y equals y plus 6. This is one set. Now, I need to take 2 other sides and put them together. I'm going to take this side and this side and set them equal to each other. Okay. Now, I have to create a system. This will give me 2x plus 2y is equal to y plus 6. Now, this is going to give me 2x plus y is equal to 6. Come. Now, in this red equation, I am going to take and move this 2x to this side. Okay. I'm going to say plus 6 is equal to 2y. I'm going to divide everything by 2. See this y? It's equal to x plus 3. Right here. 2x plus x plus 3 is equal to 6. I did a substitution here. This will give me 3x is equal to 3. X is equal to 1. And 1 plus 3 is y. 4 is equal to y. So x was 1, y is 4, AC 2 times 1 plus 4 is 10. And if you check each side, they all should be 10. Equiangular also means all sides are equal. Now, someone just asked me in the chat room, could I have done this by using elimination? Yes. The algebra to get to x equals 1 and y equals 4 is your choice. But you got to have 2 equations. How you solve those 2 equations are up to you. Any question? Okay. Now, what we're going to do next should be no surprise. This is going to be our 5th method of proving, but it's also dealing with right triangles. Okay. Now, in order to work with right triangles, there's also a little catch. You've got the box. The two legs. Now, remember from way back earlier, a leg can also be an altitude. It is the side on the side of the right triangle. So they can also talk about altitudes. Altitudes mean right triangles. Now, our fifth method, and just to make you remember, we've already talked about side, angle, side, 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 angle, side, angle, and angle, angle, side. These were what we did earlier. Now, this is known as HL. H represents the hypothesis, which is that blue side. But you must have a right triangle. This is known as hypotenuse-leg, which means one of the altitudes or legs plus the hypotenuse in the right triangle have to be given or proved. So our fifth method, coming down here, is going to be what we call HL. This side has to be marked or found. It is not going to be one of these if I have a hypotenuse and it's a right triangle. Now, there's also a second one. This is known as hypotenuse-angle. Again, right triangle. You know the hypotenuse. That is going to be our fifth method. And this is a little proof. This is called HA. First off, you've got to have a box. It's got to be a right triangle. You have to know the hypotenuse. Now, all you need is another angle. It can be the red angle. It can also be the one that I didn't mark. But if you think about this, because it's a right triangle, I know the hypotenuse. So therefore, the reason I can prove this congruent is by hypotenuse angle. Now, the other one is known as hypotenuse-leg. They call it a leg, but it can also be an altitude. Here's my box. I know this side when I mark it. I just need a leg right here. If I know that leg, and it could also be the horizontal leg, the key is hypotenuse, and you have a box. This is your fifth method, hypotenuse-angle or hypotenuse-leg. Okay. And I want to show you right here. This is my lovely proof. Okay. Now, here is a given. Christopher, technically you do know three parts. You have to be given the right triangle. That's a given. It's got to be a right triangle. Once you know you have a right triangle and you learn the hypotenuses are equal, and that's the key. You've got to know the hypotenuse. The side opposite the right angle is equal to another hypotenuse. So technically you do have three pieces. The right angle is the one that's understood. So we're using HL or HA, but we have that third angle. Great, Christopher. Now, just like any proof, right away, see that this says right angles? Okay, I want to write this up here. These are our methods to use. Side angle, side, 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 or angle, side, angle, and then we have angle, angle, side, but now we have the HL or the HA. These are our five methods. Now, the fact that I have a right triangle means I might have this one. But there's a catch. I've got to know the hypotenuses are equal. If I don't know the hypotenuses are equal, then I've got to go back to my four basic ones that we've learned through last Monday. So with that said, right here, this is one of my given. Okay. This is also one of my given. So right away in this proof, I know that in the reason column, number one is given. Okay. And I know that line number 3 is given. That's the beautiful part about these formal proofs. You don't have to search around. You know that you have two givens. I've got to have two lines in the reason column that are both given. Now, we're going to come to our marking column. Okay. That's this column. Now, it says angle R and angle V are right angles. Okay. Now, I'm going to mark a box up here and a box right here. Now, just to make life a little easier, I'm going to separate these two triangles. This is S, this is R, this is T, this is V. I've just marked this angle. So I'm going to put an angle here. Now, look at line number 2. It's telling me that they're equal. Well, notice in line 1, this is my right angle theorem. I'm using words from line 1, right here. I did. It just takes a little while sometimes, Gutmann, to get him in here. This is my right angle theorem. See these words? They're the words I'm using over here. Because why did I mark them? They're right angles. And remember, I have the little squiggle. So the little squiggle says it's theorem. Now, I've got to mark line number 2 or go to line number 3. Okay. This says RT and VT. Okay. RT is this side and this side. So mark them in 2 places. Okay. That was given. We knew that that was there. Okay. Now, that was, now, in this case, okay, we're going to call this a side, but be careful in mom. What we put here had better reflect what's in this marking column. So that S may change. And you're going to say, why? Well, wait and see. Right here. This says ST is congruent to ST. Well, notice what ST is. It's the hypotenuse. Okay. It's the hypotenuse. But the reason is its reflexive property. Now, if I put an S in that marking column, do you remember what that's going to mean? That's not one of these methods. Which means this little piece right here is going to be marked as a leg. So therefore, line number 5 is going to be HL, because this is a hypotenuse. This is the proof. Notice how on line 3, I had to change it from an S to an L. You won't know it's an L or an S until you get to this line. Because did the hypotenuse, the red, this nice little piece? Yes. Now, I don't want to go any further if you have questions. Okay. This ends to 5. Okay. Now, this is something you may not like. This is known as roots, square roots. This is also going to pull in something that you're going to have to learn. This is called mom language. Don't laugh. It's mom language. Okay. And I've got to explain to you how this language works. Okay. Okay. Now I'm going to show you how it works, but I'm going to do a couple of problems. Most of you are very familiar with radicals. Now, there are some that you're going to have to know basically by heart, or if you recognize them, great. In the future, you will be able to use a calculator because we're going to be dealing with radicals. But there are going to be times when you're going to be asked for the exact answer, which means you're going to have to give a radical answer or a whole number. Now, in this case, the index is this little number that's at the top. Now, if there is no number there, it's understood to be a 2. Okay? Now, the key is right here. Radicand. You are looking for the base of an exponent to the power of an index. Okay. May not make sense until I do it. But you also, to simplify, need to use prime factors. Okay. Now, it's easier for me to show you than it is to tell you. Now, this is going to ask you to simplify. It is also going to tell you no decimal answers. Now, they want the exact answer, which means these two problems have got to have a whole number answer. Now, hopefully, if you look at problem number 1, you know that the square root of 25 is 5. You can actually take your calculator and use it. It'll give you 5. Now, the problem is when you get to the number 529, not a nice number. Okay. Now, you're expected to do this without a calculator. Some of you are going to say, oh my gosh, well, yeah, this is a skill you're going to have to learn. Now, how do we determine what this number is? Well, I'm going to do it the long way to give you a little help. First off, you have to know that 20 squared is the number 400. Okay. Well, 400 is smaller than 529. You also must know 25 squared. This is 625. These two you are expected to know if you're going on in mathematics. This number, 529, should be somewhere between 20 squared and 25 squared. Well, that means I want to look at 21, 22, 23, 24. Now, look at this last digit 9. 21 times 21 is going to end in a last digit as a 1. That's not going to work. 22 times 22 ends in the last digit being a 4. That's not going to work. 23 times 23. Well, notice this gives me a 9. 3 times 3, 6, 6, 4. Go. Does everybody see what I did? You have to know these two. Same thing as 30 times 30. Great, Joseph. You're going to have to figure these out when they say exact. It's got to be a whole number. Okay. Now, this one gets a little more interesting. So I'm going to do 2 more to get some of you started. Okay. They're asking you for exact. 28 is not going to be a whole number. But how do we find it? Well, this is where prime factors come in. No problem, Caitlin. 28. Okay, think of 2 factors that make 28. 4 times 7. Well, 7 is prime, but 4 is 2 times 2. This is a pair. 1 pair. Okay. Now I'm going to make a little funny here. This square root, consider it a house. Underneath this house, I have 7 times 2 times 2. Now, the funny part is you can't leave this house unless you have a date. A date means there's 2 of you leaving. The 2 that are leaving are identical. They are going to go to root 7. This is my exact answer. Okay. Now, mom language. Okay, this is where the fun comes in. This 2 in mom is considered A. Okay, because it's out in front. When you put this in mom, it is going to be 2. Now, sometimes they have a space here. It's then going to be S, Q, R, T, you must put parentheses, and this 7 is considered the B. Okay. This is 2 space. Now, S, Q, R, T are all lowercase letters. Okay. But also, Mom asks you to do this. 2. They put an asterisk right here. S, Q, R, T, parentheses 7. You've got to use the parentheses for the B number. Now, I didn't finish 2-7. I'm just starting 2-7, but I will let you know that 2-7 is open. 2-7 does a lot of stuff with the Pythagorean theorem. Have a calculator, because some of these are going to ask you for a decimal answer. Put a decimal in there. You got the calculator. But when you take chapter 1-2 test, they want an exact answer. Now, I'm going to stop here today, and I will finish 2-7 on Monday. Homework. You have 2 homeworks. They have 3 sections attached to them, and they're all proofs. 2-1, 2-2, 2-3A, 2-3A, 2-4, 2-6. Those 6 sections all deal with proofs. They also deal with symbols. 2-5 is opening. Okay. 2-5 in this particular case, you should be able to do isosceles triangles. Now, 2-7, you may struggle with because there's a lot of square roots with these. And when they say exact, you can't give a decimal. I will start here on Monday, finishing chapter 2. If you have any questions, message your instructor. I'm here. So have a great weekend.